In this optimization problem, we have a kennel with 3 different cages, and we're supposed to make the maximum size kennel we can possibly make using 64 yards of fencing only. What I'm going to do is I'm going to get a top-down version of this kennel. So we're going to see a rectangle with 2 dividing walls, and so we see the 1, 2, 3 cages there. I'm going to call the long side of this rectangle, I'm going to call this Y. I'm going to call the short side X. Okay, the area of this kennel would be X times Y. Now, a lot of people think at first glance, they think, oh, it's X times Y times 3 because there are 3 cages. But it doesn't matter that these walls are dividing the rectangle. It's still the long side times the short side, which would be X times Y. It doesn't matter how many times you cut up the kennel, the area is still X times Y. Now, what about the amount of fencing being used? A lot of people think, okay, that'd be the perimeter. Sure, the perimeter is part of the fencing being used, but there are these 2 interior walls that are also being used to divide up the 3 cages. Okay, so that would be, we've got one side of length Y. Note, we have 2 sides of length Y. So we have perimeter equals 2Y plus, and we have 1, 2, 3, 4 sides of length X. We're told that the amount of fencing, or our perimeter, the amount of fencing we're using is 64, so we're going to set that equal to 64. Okay, this is what I call the primary. The primary is the function we're trying to maximize. So this is the function I want to find the maximum area for. This is the constraint. This guy tells us how much fencing we're allowed to use. So we're going to solve for one of the variables in the constraint and plug it into our primary. That's always one of the steps that we use for optimization, is solving for one of these variables here. So I'm going to solve for y. That's going to entail subtracting 4x over, so I get 2y equals 64 minus 4x, and then dividing both sides by 2. It doesn't really matter what variable you decide to solve for, but I opted to solve for y because it's going to give me some nice numbers here. I'm not going to get fractions as I would if I tried to solve for x. Now that I have y equals 32 minus 2x, I'm going to plug that back into the primary. So now my primary reads a equals x times 32 minus 2x. I'm going to distribute the x to both terms on the inside of the parentheses, giving me 32x minus 2x squared. And now that my primary is all in terms of one variable, I'm going to use calculus. I'm going to take the derivative and set it equal to 0 because that is where the maximum occurs. So taking the derivative gives me 32 minus 4x. Setting that equal to 0 tells me x equals 8. And now that I have x equals 8, I can plug x equals 8 back into my constraint, which says y equals 32 minus 2x. 2 times 8 is 16. 32 minus 16 is 16, so I have y equals 16. If I know the short side is length 8 and the long side is length 16, then the area would be 8 times 16, or 128.